Hello statistics student, this video is for chapter 3.2. Two new terms for probability, mutually exclusive and independent events. So mutually exclusive talks about two events, whether they happen together, when they're happening together or they happen one after the other. They are mutually exclusive if they will not happen at the same time. So if probability of A and B cannot happen at the same time, that's 0. I think you run into this a few times when we say, we throw a dice. Can I have the outcome being 1 and 2? Not possible. So that is 1 and 2 are mutually exclusive if you throw a dice. If I pick a card, can I have the card being a 3 and a 4? No, not possible. So, but the card being a 3 and then a red card, that is possible, right? So that is not mutually exclusive. But if it is, a card, right? Oh yeah, but I think I have this example here instead of writing it down. So if I toss 6 face dice, getting a 4 and even, so are they mutually exclusive? No, they can happen together. They can occur at the same time because 4 is actually even. So we say they are not mutually exclusive. But 4 and a 5 will be mutually exclusive because you cannot have throw a dice is either 4 or 5. You cannot happen at the same time. But what about in a two-way table? So we know that and is just one cell, right? So if I say, for example, I have a yes, no, females, and no opinion instead of yes and no, there's no opinion. So we figure that there is a 0 in a cell. So this cell means that if you are female, you cannot have no opinions. They don't happen together. So 0 female has no opinion. If you're a female, it's either yes or no, but no. So F and no opinion, the probability is 0. So they are mutually exclusive. So in a two-way table, having a 0 frequency count cell means that 2 row and column categories are mutually exclusive. Okay, so mutually exclusive is useful later on in a formula for A or B. So we need to understand what it is. The other terms that we want to understand is called independence. So independence talks about whether they affect each other. So two so when two events are independent, then probability of A and B is exactly probability of A multiplied probability of B. So in a nutshell, in the concept means they don't affect each other. They don't affect each other. Whether the other one happens does not change their probability. They don't affect. I can't write it. Oh, I'm gonna write it again here. Okay. The two effect A does not affect B, or B does not affect A, or vice versa. So when you do probability of A and B, you can just do probability of A times probability. And this is very important. And because if this is true, then we say they are independent. So when we look at a two-way table, when we are looking at how we classify subjects by two categories, we can see if the two categories are independent or they affect each other by checking this. The other way to check if A and B are independent is probability of A does not matter whether B occur or not, is probability of A is the same as probability of A given B happen. Or probability of B is equal to probability of B given A happens. That means I don't care whether you have happened or not, it's just B. Okay. So if these two either one of these or any one of these three is true, then we say they are called independent. Okay. So for example, I have a two-way table below. We want to know if choice of phones is dependent on gender, right? So we want to see if choice of phone, so they are both categorical. Choice of phone is one categorical variable and gender is another categorical variable. We want to know, well, if you are male or female, Would your choice of phone difference? Are there any correlation, right? Do they relate to each other, right? So would more female choose iPhone versus the other, right, or the other way around? So we want to see if this is true. Okay, so we will revisit this actually much later in chapter 11. But in the meantime, we can actually use this definition of independence, this one of these three formula defining what two things are independent, to analyze it. So we want to use the given thing. So check if probably of someone choose an iPhone, whether it's affected by the fact that it is a female. That means whether gender affect iPhone choice. So we would just want to find probability of iPhone. Probability of iPhone is all the people that choose iPhone will be 18 plus 24 over the grand total with 51, right? And then I want to find probability of someone choose an iPhone if that is a female. So remember, when you do given, you only use this as use this female one as the sample space. So you would add all this together as the sample space, which is 24 plus 4 plus 2. So I have 30. And out of these sample space who use iPhone, 24 of them. So 24 out of 30 is 0.8. So that means you can see that there is a difference. If it is a female, there is only 80% chance that person would choose iPhone. But if you don't know the gender, there is an 82%. So female does affect choice of iPhone, right? So iPhone use is not independent of gender. The gender being a female does change the probability of someone choose an iPhone. So we can conclude that if they are not equal, probability of iPhone is not equal to probability of iPhone given a female, then they are not independent. They do affect each other. Gender affect the choice of iPhone. The fact that you know the gender change how likely the person is going to choose iPhone. So that is one way of using this. I think I have another way. Let me see. So there's another example of checking if two categorical variable are independent or dependent. So we have a two-way table of right-handedness, left hand, or male and female. So we know around 10% of all adults are left-handed, but we do an example, we do a survey to see if it is more for male or female. So these are the results. So we want to check if right-handedness is independent of gender. So we would do male and right-handedness. To check if they're independent, we use the and is equal to probability of male multiply probability of right-handedness. So we just need to find three probability. Probability of male and right-handedness is just that cell, right? Male and right-handedness is 43 over 100. Probability of male is what? All the males. 43 plus 9 is 52 over 100. Probability of right-handedness is just this whole row, whole column of right-handedness. 43 plus 44 divided by 100 is 0.87. And it's just one cell. It's just this one, right? Right hand and male is 43 over 100. So it's 0.43. So let's check. On the left-hand side, probability of male and right-handedness is 0.43. On the right-hand side, is probability of male times probability of right-handedness. That means these two number, 0.52 times 0.87 is 0.45. They're quite close, right? But are they equal? Strictly speaking, they're not equal. So if they're not exactly equal in probability sense, they are not independent. They do affect each other. Maybe there is a higher chance for females no, for I think male to be right-handedness. So if you look at this, okay, and you can just check it really easily. Check probability of M and R. Is it equal to probability of M times probability of R? If they're equal, then they don't affect each other. They're independent. If they are different, that means they do affect each other. They are not independent. Okay. Now later on, like what I said before, in chapter 11, we'll look at this again because, well, they're so close. Maybe it is because of sample variation, right? So we will take into sample variation to check if two categorical variables are independent of it or not. In the extreme case, if one of them is 0.1, the other is 0.5, then you know that they are surely not independent. They affect each other. But if they're that close, you need probability, you need statistics analysis to see if this difference is really because of sampling variation instead of the fact that they are not independent. So chapter 11, remember, we will run into this again. For the time being, just remember for checking if a two-way table's categorical variables are independent of each other, check one of these three. My favorite is actually the first one because the conditional is kind of difficult to do sometimes, but the and is very easy. So you just have to say probably A and B in a two-way table. It's just one cell, right, over the grand total. These are either one column over the grand total, and this is another column over the grand total. If they're equal, they're independent. So I usually use this to check. Okay, so the next video will be 3.3. We introduce two rule called addition rule and multiplication rule.